So my wife bought this ring she really liked, and then she lost it gardening, and and it's out of stock. So we're gonna build a metal detector to try to find it. For today's adventure, you're gonna need a 100 nanofarad capacitor. I don't know if you can see that. It's gonna say 104 on it. 0.1 microfarads. You're gonna need a buzzer. You're gonna need a diode. You're going to need around 220 ohm resistor, an Arduino cable, some sort of power supply for it, and about 3 meters of cable. Here I'm scavenging it from an old project. For soldering, I've got my soldering iron, solder, and some cables are going to be necessary, some breadboard cables, prototype cables, because my Arduino only has male pins, so I'm going to have to attach some female pins or some female cables. Okay, so here's the wiring. The buzzer is basically just, 1 and 1. The ground went to the ground of the buzzer, and then the red went to the positive, which the red will go to data, and the ground will go to ground. And then on the coil, we have the 200 ohm resistor connected with the diode and then one of the legs, and that goes to the green cable. The other side of the diode is connected with the capacitor and the blue leg of the cable, and then the capacitor and the ground go to the last side of the coil. And then yeah, we got females on sides on all the other ends. On the Arduino end, we've got analog 0 for the green, analog 1 for the blue, and then ground for the ground. And then on the other side for the buzzer, we've got ground for the ground, and data 12 for the red pin. Okay, so the metal detector didn't work out. Basically, either the ring's not out there, or this coil it needs to be much closer to the ring to say anything, and there's a big thicket of ivy out there, and so I can't get the coil close enough. And then it just wasn't robust. This resistor right here snapped off. Yeah, so plan B is Raspberry Pi plus a radar module. Okay, so I'm going to use PyTorch, and if you go to this Q Engineering website, you can just install PyTorch on Raspberry Pi 4. Doesn't take very long. The biggest issue though is that you need a 64-bit Raspberry Pi setup. So the system is built around 3 codes. The first one is basically just a recorder. It just takes data from the radar unit. The second code is a training code, which takes the recorded data and trains the neural network on it. And then the third code is the inference code, and basically takes the radar data again live, and then it runs it through the neural network to see if it sees a signal or not. So right here is the first code for gathering data. You're going to have a million imports because it's trying to do a bunch of things. this is basically based around one of the examples from the OPS 241 library on GitHub. I'll have links down below. Yeah, you can kind of skip a lot of these things. Basically, it's just setting up the system. This is for Raspberry Pi screen, which I'm not really using, so I just kind of ignored it. Yeah, again, a lot of the stuff you don't really need, but right. So part of this is that talking to the radar module is a little tricky, and so that's why I'm using their example. And so here's kind of a function that goes through and does that, talks to the radar module. Here is the function or the system that sets up the communications with that radar module over USB. And yeah, a bunch of other communication stuff. And then here's the main loop. Let's see. So yeah, first it just kind of goes on forever until you tell it to stop. It reads the data, and it tries to make sure that it's good data, and then it parses the data, splits out using the commas and gets rid of the other stuff, and gets it kind of into an array. And then I added some lines down here. Basically, if we've gathered 10,000 lines of data, then, oh, and by the way, I set mine up to, I don't remember where I put it, but basically I set mine up to go into 08 mode, so that it gives me 8 ranges. Basically, it finds the first 8 peaks of distance measurements, just so I get a bit more data. And yeah, so it once it gathers 10,000 data points, then it writes the data to a file. I'm just putting it simple or something or nothing.txt, and then it quits. And I guess I'm looking at the wrong file, but one of them I also had, it has it beeping for me so that I know that it finished gathering the data. So here's the training system, and so yeah, you import torch and all these things. I've got some functions, which I mean, I probably could have spent more time trying to find the Python way to do it, but it was easier to just kind of write the function myself. And so yeah, I've got some like folding functions to kind of grab the lines of data and put them into one big matrix to give over to PyTorch, and some concatenation functions just to make sure that it's going the right way. And yeah, some more data parsing. So basically it loads the data, it gets an array of ones, basically saying that, hey, all these somethings should have been gotten from a real source. So those are going to be like, hey, there's something here. I'm telling the neural network there's something here. And then the nothing ones, I'm filling that one with zeros, or making another array with the same length and filling that one with zeros, and giving that one to the neural network. So basically, these nothings are paired with zeros, like there's nothing there, and some things are paired with ones, which means there's something there. And then here's a bunch of parameters. It's input 16, output 1, right? So I'm taking in 16 data points. It's basically 8 ranges, and then like the strength of the field at those 8 points. And then there's a middle layer of a hidden layer of 16, and so it's got like a little bit of neural network in there. And I trained between 5,000 and 50,000 epochs. I didn't want to overtrain, and yeah. So yeah, there's a bunch of getting the data in the correct order. I also had to, okay, so you have to scale your data. The neural networks don't like one of my measurements is in meters, and another measurement is in like kind of made up units of strength that goes up to like the 10,000s. And neural networks don't like things of 2 different sizes. So I use this standard scaler, and then I have to save my scaling if I want to use it later. And so that's what this is. And yeah, so then I kind of pair all the data together. I split out training data and testing data. That way I know if I'm overfitting. And then yeah, I write the neural network, just a linear, ReLU, a linear, and the sigmoid. pretty simple. I tried making bigger neural networks, but again, that caused overfitting. And then I tried using Atom because that's the one that everyone tells me to use, but I found the default SGD worked better. So yeah, then you train and do all the training thingies, and then you save your model checkpoint so you can use it later. And then I did some testing, and I did testing to see like the testing accuracy and the reported accuracy. That way I could see if I'm overfitting again. And then finally you have the rangednn.py file, and that's basically the same as the range file. It's it's using their it's like radar Raspberry Pi default file. But instead of saving it, at each step I give the data to the neural network. And so yeah, there's a bit of like real quick formatting of the data and scaling it. And earlier on the file, you can see that I scaled it, or I grabbed the, oh no, here it is. So here's I'm using the scaler that I loaded, and you got to do some weird refolding there. And yeah, basically plug it in. If the prediction is less than half, say no ring, and then turn the buzzer off. If the prediction is higher than 1/2, then there's probably a ring, and turn the buzzer on. And I've got this in a try except because the radar module is kind of a pain, and sometimes instead of giving me like the number of data points I requested, sometimes it just cuts it short and gives me like 14 or 12, and of course the neural network's not going to like that, and so I just ignore that data. All right, so I've got some momentary switches and some cables and a soldering thingy. And so I'm going to put together some switches that I can hook up to the Raspberry Pi so that I can tell it when to start recording. That way it's not a pain to go outside and record. Okay, so I got the system running. There's false positives here and there because the data is pretty noisy. But in general, the beeper is not beeping very often when I just have it pointing at the ground. But if I pass it over and point it at the chip, then I get a pretty annoying buzz. I guess we'll see if this translates to a ring in the grass. Okay, the code is ready. I'm on a mobile power supply. I just have to unhook the HDMI and take this outside, and hopefully I get 2 beeps. So now I am gathering data for ideally where the ring isn't. I mean, I guess there's a chance that the ring is, I passed over the ring, but hopefully I'll just get drowned out by the rest of the data. And then afterwards I'm going to use a different ring to capture actual data for a true measurement. Okay, so I placed the ring down here. I'm going to cover it up. I put it at the end of this twig thingy, so hopefully I can find it later. And now I'm going to get some training data for the actual ring. I feel like a crazy person sitting here waving a tiny circuit wand over my yard. Alright, first I'm going to train 5,000 epochs just to see if the data is good at all. It shouldn't take too long. And if it's good, then I'm going to go up to 50,000. Okay, so I trained the neural network again on the Raspberry Pi. I tried a few different hyperparameters, but 62% testing accuracy is basically the best I can do, which I guess 63%, which isn't great considering, it's yes or no, so 50% is, knowing nothing about the system. But yeah, so I guess it turns out this radar thing isn't great for finding objects outdoors. So I duct taped the radar module to the end of this camera stand. That way I don't have to stay bent over the whole time, although with the amount of false positives I'm thinking I'm going to get, like that, I'm guessing I'll probably bent over anyways, but we'll see. Okay, well I put the ring back in the same hole where I gathered all the training data, and I'm not getting anything out of this. So I'm starting to think this is not going to work out. Well, that didn't work out, but I learned a lot about PyTorch and I guess small electronics, and yeah. So I don't think I'm gonna buy a fancy metal detector, but I do have some coil laying around, so maybe I'll try to make the other kind of metal detector where it's like two coils side by side. But yeah, thought you guys would want to see my failure.